No, I'm fine. Just have to find out where to plug it in. Oh my lord, our projector has an IP address. Probably means it's got malware in it. Okay. So, we're going to start with this. If I can figure out a slideshow from the beginning. Lord. So, very briefly, there are probably two people in the room who don't know exactly why IP address spoofing is a problem. So for you, I'm going to sort of set the backdrop of what RRL is designed to solve. So the essence of all of the attacks you've been reading about, other than the low orbit ion cannon and some of the other GET request floods that some of the banks have seen, all of the packet flooding attacks you've been reading about on the NANOG list or in the newspapers in the last 6 months use this mechanism, whereby an attacker who is able to use someone else's source IP, in other words, the victim's source IP address on a request, sends that request, and the reflecting, amplifying orbital death ray projector, which is your DNS server most likely, or perhaps it would be Matt Larson's DNS server for .com, will answer it, because it has no idea by the time it has been through the great internet cloud in the sky that that IP address makes no sense for coming where it from. All it knows is, gee, it came out of the cloud, I better answer it. When I first started talking about this, BCP38 was about a year old, and I wrote a companion document meant for pointy-haired bosses. I'll have a reference to it at the end of this, where I said, gee, we really need to be stopping this at the edge, because when a packet first enters the great internet cloud in the sky, that guy knows that that source address would make no sense. And so I've been working very hard to get that done. But what it looked like at that time is that the attacker would be a botted PC, and it was running whatever set of malware it had picked up recently. It's behind a NAT, and that means a lot of these spoofed source IP addresses would die right there at the NAT box. Because if you're in 192.168.1.7, or if you've got an IP address that's inside RFC 1918, chances are you cannot use someone else's source IP address on a packet that leaves your network. So it's only NAT that has saved us from an even worse set of problems related to source IP spoofing. The other thing that was great back then is that these boxes were generally megabit speed connected. DSL was the order of the day, and so even though these boxes had terrible sysadmin, they didn't have a whole lot of computing horsepower. You had to really gang 10,000 of them together to get enough packets to really hurt somebody. Not that 10,000 was a hard problem. But things have changed. Now we have the cloud. We have all of these virtual hosting clouds, and I don't mean to pick on anybody, so I won't name any of them, but you can now order a Linux VM from anybody, and they will push a button and clone that VM for you, tell you its root password, and then you have some virtual box running in somebody's cloud somewhere, and it tends to be gigabit connected. Unfortunately, these are as poorly sysadmined as the old botted PCs are. And once that button has been pressed and you got your clone, you would stop getting any kind of updates, in particular to something called Joomla or PHPBB or anything else that would allow bad people to come and use your computer for their purposes instead of just for yours. And these tend to be gigabit connected. There are millions of them. Don't downplay this problem. You can now get enough horsepower from enough different clouds that you don't strictly even need to reflect off of anybody. You can bury someone in traffic that they did not solicit and cannot stop just by spoofing some other address and firebombing them directly. Oh my God, I apologize for all these pop-ups. So in other words, the problem has recently gotten much, much worse. And of course, the cloud owners will tell you, yeah, we gave that guy the root password. We cannot now reach past him and update his software for him. And we understand that he's not smart enough to do it, but we'll pass your complaint to him, which he won't understand. That's the direction we're moving. So in the future, this projector, since it has an IP address, will no doubt have malware running in it, because you've all heard about SCADA, industrial control systems, getting default passwords running telnet or whatever. The idea behind these boxes is volume. And at scale, security gets lost in the noise. I'll explain a little bit about that. And again, this tends to be your DNS server. I'm going to explain what you can do about it in the other half of this talk. Right. I don't know what we were thinking. UDP in the wide area is crazy. It works fine for NFS or anything else that's in your LAN or on your campus, but I don't know what the heck we were thinking, creating a protocol like DNS and expecting the whole world to run it and not have this problem. I really don't know about DNSSEC, because some complete moron wrote an RFC number 2671 that allowed for the response to a packet to be a lot larger than the old 512-byte limit in order to accommodate the gigantic signatures that come with DNSSEC, especially negative responses. So we were crazy. We're hurting from it. We could have seen this coming. Now, to add to that, sales of smartphones and whatnot go up if it has flashing, moving things on it that you can press and so forth. And that means apps. That means pulling data over the network, promoting it to code, and executing it in some form, like Java, Flash, ActiveX, whatever. I don't know what we're thinking, because every one of these has had all kinds of problems where the executable data gets corrupted or is deliberately corrupted by its creator and then co-ops your box. Soon it will co-opt your refrigerator. And lastly, you can't expect somebody to be a sysadmin. I understand that the iOS devices, iPhones and whatnot, get this better, but thinking that PC, Mac, cloud servers, smartphones, any of these are going to, that your mom is going to sit at home and say, it's time for me to update my software because there's a Java flaw, that's not realistic. So we really could have seen this coming. If you have a recursive name server and you're open to the world and you're not Google or OpenDNS or some other entity that is really dedicating a lot of time to filtering abusive flows, you probably need to close that and figure out how to answer queries only for people that you treat as your users, your customers. You can do that with access control list. You need rate limiting. I'm going to explain what that is. If you run a network that's at the edge and you have some customer that you're feeding connectivity to in a data center or over a T3 or whatever it is, you could filter any packets they send you that doesn't have an IP address that you've allocated to them. And if they say, but wait, I'm multi-home, then you make an exception for them. I'm not saying you should never do it. I'm saying the default should be don't do that. Keep people from doing this. And this business of giving somebody cloud servers without any kind of hope of ever having any sysadmin again after day one is a bad idea. So there needs to be some kind of a premium service where you pay an extra $1 a month and get updates applied for you. I promised you some references. Dan Cini and Paul Ferguson wrote BCP 38. I noted that it was too long and too complicated for pointy-haired bosses, so I wrote SACO 04. I recommend printing both of them and then distributing them among your workplace to the pointy-haired and non-pointy-haired bosses. Okay, that's to let you know why we're here. Now to tell you what I'm here to tell you. There's a fix for this on the DNS server side. And like all fixes, it's not perfect, and yet it is working pretty darn well. So I talked about this. This is an actual demo on my actual recursive server. What you're seeing is a burst of 25 requests, and I'm telling the dig command, don't fall back to a TCP session, and a bunch of other things, don't retry and so forth, because if you let dig work normally, then it will time out and retry, and if it gets a truncated response, it will retry with TCP and so forth. So without all these fancy options, you just get 25 decent answers, even from my server. So I had to, in order to demonstrate that I'm dropping some of this burst, I had to turn on these extra options. And all this is really saying is, yeah, out of 25 times, we ended up with 3 truncated responses. If you set the TC bit, that tells the questioner, yeah, I didn't have room in the packet for everything I wanted to say to you, so if you didn't get enough, which they won't from us because it's a zero-length response, then you should try again with TCP. This is dangerous because TCP is 3 round trips and 7 packets and a lot of state on both sides, and it will not scale. So you can't be doing this all the time, but you can do it statistically. So we have a mixture in RRL, response rate limiting. We have a mixture of setting the TC bit on some things and dropping some things. And the result is that you get no actual loss. You get a little bit of extra delay if that particular person is under attack and that particular name is under attack. This is what it looks like in the config file. I'm simply stating here that I'm going to remember 5 seconds of history for anybody who has exceeded the maximum of 5 responses per second. Now, to be a response means not just that your IP address asked me something. It's an IP address similar to yours, bucketized down to the /24 if it's IPv4, usually that's the default. An IP address similar to yours has asked me a question that had an answer similar to the one that I'm thinking about giving you. Because otherwise, somebody could just randomly pick, randomstring.com and another randomstring.com and so forth. Every one of them would be a unique reply. And you would not necessarily be able to detect that as a flow. But from our point of view, a negative response is actually a response from the apex. So if I ask randomstring.com and I get a negative answer, we treat that as a negative answer from .com. We ignore the random string. So we haven't seen negative impact on real flows. Now, Andrew Sullivan pointed out recently, last day or so on one of the mailing lists I'm on, that for a CDN provider with really low TTLs, this is bad. This is bad juju. Because if your TTL is lower than the average time of the retry, then you're going to end up not giving good response to these CDN names. I'm not a big fan of CDN DNS, but I still recognize we should fix this. I just don't know how yet. Other than that, no negative impact. When we threw these patches out there, a number of people were being attacked at that time, in that moment, and publicly stated, both at Affilius and Nominet for co.uk, that they threw our patches in without nearly the testing they would have preferred to have, but their house was on fire and they had to do something, and it worked. So if in an authority server, I just recommend that you turn this on. In a recursive server, it doesn't help, because repeated flows on a recursive server are probably coming from some postfix or sendmail or Apache or some server on your network, and they really legitimately do ask the same question many times because they have no cache. So this won't help the recursive side. That's why I started my other talk by saying on the recursive side, what you need is an ACL. Make sure that you're not answering questions that didn't come from your customers, and you probably won't need rate limiting on the recursive servers. It's not bind specific. A number of people think that everything I do has to be bind related. That's not true. This is a DNS thing. And to that end, I want to note that NSD has just implemented this in 3.2.15, which was released a day and a half ago. And they used the same logic, but of course completely independent source code. And that means you don't have to run bind to get rate limiting anymore. Other server operator or implementers are certainly encouraged to also implement this. It is something, it's a public health hazard to operate a name server that can be an orbiting death ray projector for anybody is a public health hazard. Don't do it. If you don't currently run bind or NSD, then consider switching to one of those and telling your current DNS server provider why you did that, and point them to the internet draft looking document that I wrote that describes this. It's not patented, it's in no way protected. I want people to turn this on. Now that it's been implemented across 2 servers, I will be submitting an internet draft and letting the IETF take a swing at it. Obviously, if I'd started this with an IETF document, then it would be 16 years before we had the ability to run code anywhere, so I didn't want to do it that way. There's a mailing list. If you don't join it, but you think this is a good idea and you just sort of turn on rate limiting anyway, that's fine, because this rate limits mailing list tends to be people arguing about how it should work rather than people trying to find out how it does work. This is safe technology. Don't worry about it. Any questions?
People, while Warren's walking up to the mic, is there any thought on deploying this similar technology for other applications, or is it generic rate limiter technology for a kernel?
So you could look at other wide area UDP protocols, and here I'm looking at NTP, and say every one of these needs some kind of rate limiting. That's not exactly true. There are some NTP family protocols that have a larger response than the request, and that was the administrative window where you could ask some clock, what are your peers, and get that list. That was a problem. That's amplification. But everything else NTP does has a response that is equal in size to the query. And that means there's no benefit to bouncing your attack off of somebody. If you're able to spoof the source IP of a packet and you're able to send a certain number of packets having a certain number of octets in them, you may as well just send them straight to the victim as to bounce off somebody who won't amplify. Now, very few people are crazy enough to put an NFS server out on the open internet, but that would be a great amplifier if they did. Most people have learned the lesson about not doing it with the Samba program. So really, although I think the IETF should adopt the attitude that responses shall never be larger than requests for all new protocols, there aren't any other there's no other low-hanging fruit. There's nothing else that needs to be fixed as desperately as DNS needs to be fixed. Warren.
Warren Kamari, Google. So more of an observation, the NANOG network does not do BCP38.
I love that. I noted the same thing when I was at a RIPE recently, and you'd like to think that we should at least be able to do this for ourselves, but I'm betting that if we found the poor son of a bitch who had to build this network, he would say my equipment won't handle that, or it does software switching if I enable that option, or there's some vendor reason why I can't do what I should have done. And in that sense, we need to go after the vendors and let them know that this is a public health hazard, and we're going to stop buying their stuff until they fix it. Yes, sir.
David Barak, AT&T. Are you starting to see some of the DNS appliance vendors expressing interest in implementing RRO?
Yes, I am. Cloud Shield in particular, which is I didn't really realize this until after they got bought by SAIC. They are an astoundingly smart company in the way they build hardware and so forth. There's a language called Packet C I recommend you all Google and read up on. It's co-designed by them. They've got a hardware device that they can front end at whatever your front end speed is that they are now adding RRL to, specifically because they haven't been able to solve this problem by counting requests. Right, so if anybody tells you they're going to solve this problem in their firewall by looking at client IP, or maybe they're even going to look at the query, but they're not going to look at the response, send them to me and I'll explain why this has to be done as a response rate limiter, not as a request or client IP flow limit. But so far they are the only ones who have picked up on this. But I know that once one of them sells it, the others are all going to start losing RFPs, and then they're going to implement it also.
Thank you.
Hi, James Schenk from Team Cymru. Have you given thought to the possibility of this being used as a denial of service attack to keep domains down and not propagating by spoofing a address in a /24 as a source and not allowing the answers back?
Yes. We wanted to make sure that in no case would we ever make the situation worse. And Andrew Sullivan has taken the time to point out that there is one case where it gets worse, and that's where the TTL is so low that the total transaction time that we can induce if there's a retry and a timeout retry, or maybe retry with TCP, is larger than the TTL. That's the problem. But in the normal case where the TTL is an hour or a day or whatever we normally use for TTLs, the answer is no, because the real client is going to be getting some of our answers. Right? And our answers are a mixture of the real answer, a timeout, which of course the client will see as a timeout, and a TC = 1 response. Now, if they get the real answer, they're satisfied. If they get a timeout, they're going to retry, usually 2 more times. If they get a truncation, they're going to retry with TCP. Now, if the channel is so congested that their queries are being lost and they can't successfully retry. That's a problem that we came here to solve, and I have to say, in some cases we don't solve it. But in the other two cases, we didn't make it worse. If somebody is spoofing your IP address, asking his server for a certain name, and he's running RRL, he will eventually stop answering that question if you ask it. But you'll be very happy that he didn't congest your upstream link with all of the responses that you would otherwise have gotten, because that dramatically increases the chances of you hearing one of his TC=1 responses or hearing a real response that he will send you. And because you have a cache, once you have it, you'll keep it. So
Right.
the answer is yes, we thought a lot about that.
But using the bit masking for matching on the source, if I choose an address that's one above or in the same /24, but not the DNS resolver that I'm wanting to block a domain from being resolvable from, then wouldn't it be possible for me to keep a particular domain from being resolvable from a particular resolver by spoofing an address that's in the same /24 and keep asking a question that server would then not cache because it's not receiving it?
So it wouldn't matter if you picked one-off IP address or picked the actual address. Either way, we will suppress responses. What we're trying to do is transform an amplifier into an attenuator. That means we're going to drop some responses altogether, and we're going to turn others into TC=1 responses. You have, with the normal 3 retries, you have an 87.5% chance of hearing a real answer from us through the normal retry logic of a normal recursive name server. And that, frankly, is good enough for me.
Okay, thanks.
Ed?
Hey, Ed. One of the thing to keep in mind here is the scaling of this. Doing this processing, to do the rate limiting, you're taking time out for your CPU. I'm not debating whether this is useful or not. It's very useful, but the consideration here is it's taking time out of your runtime resources to do this. So you're kind of shifting the attack now from, do you have any thoughts about what do you think are the scaling bottlenecks? What do you think is going to be the thing that goes, at some point you're going to have so much traffic, or what do you think would make, what could blow this out of the water, basically? What do you think? I'm asking out of genuine curiosity, not
Sure.
trying to.
So the additional resources that you will use if you're running rate limiting are the other guy retrying more often, so there's a certain network load that you're incurring, you using more CPU time to make this decision, and you using more memory to keep track of what the IP block has asked for what thing recently. We limited all of that to the extent possible, and it turns out to be perfect. We can, on a server that was receiving like 50,000 queries a second, each from a unique IP, each asking for a unique name, the total amount of additional heap space that we will require is a couple of megabytes. And as you know, servers that get 100,000 per second are not getting from unique queries or unique IPs to unique names. So that really is the worst case. And for the CPU, we don't actually marshal, at least in the bind implementation of RRL, we don't marshal the response, right? Once we know what the response would be, that's when we check to see if there's a bucket open for this and if we've exceeded its quota. And that means that in any case where we are suppressing a response, we are also avoiding the cost of marshaling that response. And that marshaling cost is much higher than our dropping cost. So it does mean that we have an additional fixed cost on the responses that we don't drop, but I'm not worried about those. In terms of actual server headroom, you can't see this. If your server was running at 10% CPU utilization, 90% headroom, you might be able to see 1/3 of a percent of difference if you turn on RRL. But it just, we wanted to make sure that we weren't creating a resource vector to trade out for the old vector. Michael.
Michael Sinatra, ESNet.
You'll be the last, by the way. I'm way over time.
Okay, just to, I'll be very quick then, just to address briefly Ed's comment. In experience running this while under attack, the biggest problem with CPU and with server utilization is actually when you're trying to do query logging while you're under one of these attacks or while you're being used as one of these reflectors. If you're trying to query log to syslog, that's going to take up a lot more resource than running RRL. And the other
point to make is, as someone who has experienced being a reflector, this is the best way to handle it right now that I know of, with very little collateral damage. And everyone, I think, is going to want to be looking at this stuff, because you either have had this happen to you, you're going to have it happen to you, or it is happening to you right now. There aren't that many other categories unless you simply don't run an authoritative name server.
So you didn't ask a question, but I'll add on, which is...
I could put a question mark on the end of that if you want.
Thank you. So a number of people have turned this on, not because they thought they were under attack, but because somebody told them this was a public health thing that they should just do, and they discovered they had been under attack. They just hadn't noticed it before. But I've seen traffic graphs that say, yeah, this is when I used to have to send 5 megabits of constant response traffic. 5 megabits is not very much by the standards of the people in this room, but it was a lot to that guy. He thought it was necessary, and it turned out that actually about a half a megabit was all that was necessary, and the rest was okay to drop. So I think you'll find that there's a lot more of this going on than anybody knew. So thank you all. I'm sorry for being over time.
That was great. All right, I'm going to present something that is on behalf of somebody else real quick, and then Larry and David, I'll ask both of you to come up shortly. Daniel Clemens and I had a discussion about some work that he had forwarded to me just sort of on a whim, I think, and I took a look at it and I thought it was quite interesting, and I said, why don't you come to NANOG and talk about this? And he wanted to, but he couldn't make it, so he said, why don't you go ahead and do this on my behalf. So basically this is some work that him and his colleague, Zach Payton, had done about a year, maybe a year and a half ago, taking a look at who Anonymous is, what are they all about, how to monitor them, and the tools that they use in analyzing those tools. So I'm just going to kind of summarize for you this white paper that he wrote. Now, I don't have permission to distribute this white paper. I'm going under the impression that any of you want it could get it. You just have to ask him. So if this seems interesting to you, either ask me later or write down this email address, and I'll happily put you in touch with him. I'm going to go through this kind of quickly in the name of time, but if those of you who I hope are very few aren't familiar with Anonymous, I mean, their modus operandi is pretty straightforward. Most people consider them a dissident or hacktivist operation who really took prominence a few years ago when Tom Cruise was in this video on YouTube that just kind of went viral, and when YouTube took it down at the request of Church of Scientology, a group of folks kind of went nuts about that and thought it was, some sort of violation of their right or freedom to post this material, and so they started launching all sorts of interesting and very often malicious protests and attacks against that group. And then from there, their popularity continued to rise as more people sort of joined the group, and they took on so-called operations, and there's a number of them. Undoubtedly, many of you have heard of some of these attacks, and so this is just sort of a brief snapshot of a couple of those that I just wanted to list for you here. Daniel's work, what I found most interesting about it is him and his colleague essentially went through almost 40 pieces of software and examined them, mostly from the standpoint of source code, and tried to identify ways to fingerprint the attacks that they would generate. And so I found this really interesting because I think that's really potentially useful information for anyone who's particularly on the receiving end of that attack. And so they built signatures for all sorts of stuff. Mainly the tools that they were looking at were focused on this low orbit ion cannon stuff that some of you may have seen. Started as a simple Windows application that would just essentially blast packets, and it had a few parameters on what to actually send for traffic. They built snort signatures because they felt that was either who they were writing this for, or perhaps based on their experience, that was most convenient for them. As I was reading this, though, however, that may not be entirely applicable to many people in this group, because I imagine some of you who have very large networks don't tend to run snort inline in some of your 10 gig links, so it's just not going to work. So in essence, many of these signatures just aren't going to work for many of you, and these would be pushed perhaps towards the edge. And I took a look at one tool to see if there were things that you could implement in like a simple ACL. And the one I looked at, for example, is Solaris, and I didn't see anything really obvious to me like that you could do like on layer 3 or layer 4 that would do the similar sorts of things that they had done. The thing that also stood out was that the attacks generated from these tools that they were doing signatures on was largely based on the default use case of these tools. So basically you download this tool and you run it, and then the signature is based on the default parameters of that tool, which are actually pretty dumb. There's all sorts of you've been hacked kind of strings in the attack payload itself and those sorts of things that are easy to filter on if you have that deep packet inspection capability, and if the attacker isn't actually changing anything about the config of the tool. So there's some limitations to the signatures that they've created, but presumably in practice that doesn't happen all that often. Here's just a quick screenshot of one of the JavaScript-based ion cannon stuff, and below that is a sample signature. And I don't intend for you to actually read that, but that's just what it looks like. So that's essentially it. They didn't find any backdoors, and they weren't able to do complete attribution to who wrote some of this stuff, but they were able to find a few breadcrumbs for some interesting parts. And so that's all I wanted to share with you. If you were interested in more of this sort of thing, you can certainly talk to me about it, but I might just refer you back to them. So that's that. If anyone has any questions about it, feel free to get up to the mic. I have one more brief thing, and then maybe I'll start with David, because I know you've tested your laptop. All right. So one of the things that I've been slowly working on, and to be quite frank, I haven't had a whole lot of interest in, is this, or success in quite yet, is these so-called DNS any attacks. And this is related very much to the things that Paul was just talking about. What this is it's a type of amplification and reflection attack that's going on in the wild practically all the time. At least every day I see some evidence that these are happening. And my view of the world is relatively limited, and some of you have much bigger views of the world, and so presumably you would see even more than I would. The idea is that you send in some type of any query to a server and you'll get a response. When you send in any query, you get basically anything that server can tell you about that query name, whether it's an MX record or a text record, an A record, a quad A, all the DNSSEC record types. And usually, or often, that response will be quite large, and so that's the amplification. So you couple that with the spoofing capability that some networks still provide for, and then you have that reflection piece. These have been going on for at least a couple of years now, specifically these in any attacks. And I've asked a couple of times, has anyone figured out, who's doing this? What's the code that's actually being run to enable these? And no one seems, as far as I can tell, knows the answer to that question. So I'm just getting sick of not knowing. So while I'm not personally or directly being harmed necessarily by these attacks directly, I'm just interested in figuring that out. So I'm trying to figure that out, and at the end you'll note that I'm asking for any assistance that some of you I know could help provide. So I essentially said all that. Well, let me back up and say what we do see often is the in any queries tend to use a handful of query names. Often it's isc.org. They provide a large response for an in any query. Write.net's another popular one, but we've seen a few others, but those are the two most well-known ones, or the most common ones. As I've been looking at this the last few weeks, the evidence that I've gotten, quite a few of these attacks, while they've been widely reported in the operator community, the operators being the DNS operators, service operators, I'm also seeing evidence that a lot of these attacks are actually geared towards gaming servers. And at least one of or a couple of the attacks seem to be particular types of gaming servers. Counter-Strike, for example, seems to be one that's getting hit with these. So that's some clue, perhaps, to who's involved in some of this stuff. The other thing I see that I don't know if it's actually related or not yet, but it's awfully suspicious, is we also see query names for simply root, so not isc.org or any. And I don't know that this is attack backscatter or not. I see these queries essentially being spread all over the net. So I'm getting queries, all the address space that I have visibility into. And I don't know if this is someone simply scanning for name servers that will respond to in any queries, and if they get a response, or if it literally is backscatter traffic from an attack. So this may be a completely separate thing to investigate, but if they're related, I'm investigating that along at the same time, that in the hopes that this will lead me somewhere. So, how do you mitigate this stuff? Well, obviously, Paul talked about RL, which is very popular. Any networks who do anti-spoofing is a problem. I've, in fact, talked to people here this week who've admitted that you can't always do anti-spoofing filters for various reasons that some of you, I'm sure, are aware. One of the things, it's not necessarily a mitigation technique, but it's perhaps a reactive approach, is to figure out where this stuff is coming from. Based on what I've seen so far, I'm led to believe, although I can't prove conclusively, is that many of these attacks don't appear to be that well distributed. They may be coming just from a handful of networks that, of course, allow spoofing. And therefore, there may be a small handful of networks who are the ones that we want to look at and sort of beat down with the hammer or get attention of so that they can help us fix this. How do we do that? Well, some of the networks that may be involved in this, and again, I don't have evidence, but I'm getting the sneaky suspicion that they're networks who have operators that are not necessarily that friendly to people in this room. That is, they're not necessarily unfriendly, but they're not necessarily going to go out of their way to play nice in the security community or spend a lot of time helping us out. So how do we get their attention? If we wanted to get their attention, do we de-peer them? Do we start announcing their prefixes with their ASN or our prefixes with their ASN in it? And since they can't get to our networks, that will maybe get their attention. I don't know, but maybe it's time to get a little more aggressive with them. So I suggest that. And lastly, I'm looking possibly for help from many of you who have visibility, particularly backbone operators, or people who have maybe access to so-called interesting customers. And I'm not suggesting that any of these specific hosting providers are bad actors, but this is some example of some in any related traffic, either victim or target or sources that may be occurring that I haven't been able to get good contact into. And I've been told at least a couple of these I'm not going to get that contact for these networks. So they're just not the type of people who are going to play nice with people in this room. But so maybe some of the upstreams might be able to help us in that situation. So if you can help, or if you're interested in helping, or if you're at least open to help if I come asking, that would be good to know, so come find me, I'll find. So if you have any questions about this stuff, come up to the mic, and I'll let David, if you want to come up and start getting ready. Go ahead, Ed. Do I need to leave the slides up?
Probably a good idea. Can you go back to the mitigations? I had submitted a lightning talk, which I haven't heard back on, where one of the mitigations that we had been looking at is trying to actually kind of change the protocol in a way by just denying access to any queries under UDP. And I'm going to save you the entire detail of my lightning talk. But that's another way to say we're just not going to answer anything that comes over UDP for any. And we can argue about good or bad, but there's a lot of thought behind it. But that I would add it to a mitigation.
But it doesn't have, the problem is, doesn't necessarily have to be in any query. That just happens to be the one that's actively being abused.
Yeah, I mean, we can go into the rationale. But the other thing that I was going to add was when preparing my slides, I went and asked some folks about the backgrounds, because we were looking at one particular attack that was talked about at the last NANOG. One of the any query attacks that we talked about, there was the BOF, the security track, whatever, last time. And I was told that since then we have seen the any query attacks just proliferate in unrelated ways. There's just a lot more use of any in many different ways to attack servers. So it's become more of a problem across the board, not just one particular use, one particular case, one particular incident. It just seems like more bad actors are using it in different ways to do different things, well, the same thing. And that's where we were part of our rationale behind looking at, has the any query become a tool of the bad only? Before, not many people used it. I mean, it was low. Now it's a big part of our traffic. It's all bad traffic. So maybe it's time to say we should really put it away. So that's for a longer discussion.
Michael Santra, ESNet. The bad guys have already started using other queries. Even in mid-attack, we saw them switch from any to RRSig for a particular domain that had RRSigs in it. Now, obviously, RRSig is an easy one to go after because it's big, but they'll find something else to do.
And related to that, too, is a couple of cases I've seen, a couple of networks who've given me packet captures There have been still been in any, but they have been for large number of zones that server has been authoritative for, and it clearly someone was targeting because they have to know that they have their authority for these zones. So the attackers are currently very aware of how to aim these attacks and how to do them. Well, we're changing PCs here. Darren, we had an idea that we wanted to do like some security personals like the peering track would do. And I know some people were interested in sort of meeting people in the security community, sort of help get in the secret handshake clubs. So one approach to do that is to have people sort of come up and introduce themselves, say a little bit who they are, who they represent, what they need help with on occasion, or what they can help with. So Darren was one of the ones that I talked to about this, and he was willing to be one of the guinea pigs to stand up and do this. So
sure, I'll do it. So I'm Darren Grabowski. I'm the OTJ at the other than Jared at NTT. So I manage the security team. So I'm actually more on the operational side of it, where Jared is the development guy and does a lot of things and has his hands in everything. So Darren Grabowski with NTT, AS 2914. If you have any problems, feel free to come talk to me.
You want to jump up? If anyone wants to jump up and just introduce themselves, feel free. Well, he was getting ready.
Hi there. I'm Brian Sniffen. I'm from Akamai. Mostly I've been a cryptographer and a web app security person higher up the stack, and we've started finding cases where it doesn't matter how much we get some of those issues right. So I'm here looking for interaction and advice on getting things right at other levels of the stack.
Hello, my name is Eric Rosen. I'm from Red Hat, and I'm on our InfoSec team. And I just came here to meet more people and start networking. So.
We'll make this the last one. We'll do some more after.
Hi, my name's Liam Hines. I'm in operations at Dynamic Network Services. So I want to talk about DNS and the any attacks. I'm here.
So I'm David Barak with AT&T Consulting, and I wanted to say a little bit about some of the sensor networking concerns we've run across in some of the edge network deployments. Some of you are involved in deploying sensor networks, and some of you are not. So just a quick overview of what sensor networks are. Basically, these are the things when they talk about the network of the future, the Internet of Things, and things like that. That's that. Okay. But the real examples of this are your smart warehouse, where every toothbrush has an RFID chip in it, or every pallet of toothbrushes has RFIDs in them, or the smart meters on every power grid, or on the power grid, or things like that. These often are multicast users, or I should say multicast sources and receivers. Often the entire communication path is largely multicast. This can cause some very specific issues. One of the reasons for using multicast in that context is because you have so many possible sources. If you think about every toothbrush in a Walmart, right, or more to the point, in the Walmart warehouse, every toothbrush, that's a lot of toothbrushes. So if you can track them all with, send one multicast and then they all get it, right? Then that's a lot better than having to individually send the packet to every single one saying, "Are you still there?" In general, the sensor networks do tend to be machine communication to other machines and not directly for people. There will be processing and then it goes to people. Also, if anybody, I'm certain there are other public transit users in the room, but many of the public transit next bus utilities are enabled with sort of almost a degenerate case of sensor networking. That could be effectively an iPhone on a bus, right? I mean, it could be something that simple. But a more elaborate case can involve sensors that are put around the city, and it tracks where it is based on proximity, things like that. So smart power grids are an interesting case, and to look at an example, I wanted to use Orlando. And I have not been involved in the deployment of the smart power grid in Orlando, so but this is just as a case study to give you the number and scale of what you're looking at and where the possible security threats are. And these are representative of what we've seen in other contexts. So there are 238K people in Orlando, and there are approximately 121K homes. That does include multifamily homes. If you take out the multifamily homes, you're talking about approximately about 57K individual structures. Something you need to be aware of in this is that your control servers of your sensors need to be able to deal with the fact that sensors are constantly coming and going. Sensors tend to be small, and they tend to be cheap, and they tend to break. They tend to be extremely low power, and they will come and they will go, and you have to be able to deal with that, and they will burn out. And if you're being concerned about security, you have to recognize that there will be sensors that will become compromised, or will become flaky or dangerous, and it will become problematic in some way, and you need to have a way to cut them off from the network. So you're the equivalent of a remote triggered black hole, effectively, but you need to figure out how to cut them off at the closest point so they can't do anything else to you. And generally, you'll have an ACNAC system in place. And I mentioned about why these would be used, why you'd use multicast to monitor them. Okay, your threat model. Obviously, your biggest threat in any context is always insiders, and that's always the largest threat in any environment ever. In any room, in any organization, there is a certain percentage of that organization that can be assumed to be working counterproductively, shall we say. And it's not specific to sensor networking, so I'm going to consider it out of scope for this, but that is the single largest problem. The denial of service threats that you have to deal with include the rampant copper theft, which in the sensor networks we've seen deployed is a huge problem, because these tend to be low bandwidth. They tend to be provisioned over cheap copper, and that cheap copper, unless you've done something like coat it with tar, so that nobody realizes it's copper, tends to be an extreme target of theft. If you're using Zigbee or you're using some other wireless technology, you get RF jamming. You can get GPS jamming. You can get all kinds of jamming of anything that's wireless. And if you can also get obviously the resource exhaustion, the amplification attacks, and the other type of denial of service you get is, of course, a self-denial of service, when you implement something and then you knock yourself offline. And generally that's security gone wrong. Now, the bigger problem in your power grid is not denial of service. It's going to be data compromise, because you're under regulatory concerns about not letting your data leak, because you have personally identifiable data about your customers that you're not allowed to share. And so there, and in Cabela's, route injection hijack is a humongous problem, as is any kind of the tapping attacks or wireless sniffing attacks. Additionally, if somebody can inject false data into your network, it's very difficult to recover from that. That's the Stuxnet attack, effectively. Once you can inject false data, how do you ever recover from that? So it's extremely difficult it's easier to prevent these than it is to recover from them. And denial of service and data compromise do fight with each other, because the more you do to prevent your data compromise attacks in terms of anti-replay and the like, the more likely you are to cause yourself a denial. The more easier it is to knock you off the air. So that's an omnipresent danger. So looking at the example topology, you'll have some degree of home aggregation. That'll have access points that'll connect to your cloud of some kind. It'll go to your data center. Some number of homes are aggregated for every access point. Given that you've got 121,000 homes, you're probably looking at between 1 and 10,000 APs. That is a non-trivial number of APs. So whether or not your sensors are your multicast sources or your APs are your multicast sources is a significant scaling concern, which will tell you about the amount of headroom you'll have in terms of a resource congestion attack. Do you really want 121,000 S's in your S, G on your switch? Routers can do it, but switches tend to be pretty unhappy with that. And if you do that if you want to do that on your routers, watch out for hash cable collisions, because that gets pretty unpleasant. So the types of attacks that you see, so your denial of service attacks take place in different places and can be mitigated. You're jamming in copper, you can't really mitigate copper theft other than you can mitigate copper theft by using wireless backhaul or using some non-copper backhaul, but that gets kind of expensive. But if you use non-wireline backhaul, then you get more jamming. So comes up. Using non-internet backhaul can mitigate some of the capacity flooding attacks that could come from the internet. The data compromise can be mitigated via encryption, but you can also give yourself a self-denial of service when you do that. And so that's where that'll take place. The trouble with your malicious data injection is actually capturing it and knowing when it begins. Because once you capture it, that's when you need to cut it off. Basically, the moment you see it. Once you've let it get in, and you say, "Oh, we had a malicious data source 3 months ago. How long has it been spitting in data, and how long has it been able to corrupt the other sensors and the data from the other sensors?" The way you do encryption, you can either encrypt from the AP back and then across your network, or you can encrypt end to end. And end to end is cleaner, but it also means that your multicast scaling gets harder because you don't want to try to unless your encryption is at the application layer, because then taking your non-IP data and then figuring out how to IP encrypt it gets kind of difficult. And it may be worth it. It may be worth it to have a dual layer of encryption, to encrypt it at the IP layer and at the IP and RF layers, as well as at the application layer. And there is no actual amount of protection you can give that will prevent a sufficiently determined attacker. However, the goal is to make it difficult. So, but it will not prevent someone who's sufficiently determined. As we've seen from networks that are disconnected from the internet entirely and still get hacked. And still get hacked to the point that their controllers spin out of control and explode. So these are some of the concerns we've seen and basic mitigations that we've been looking at and recommending. Are there any questions?
Sure. I don't think that mic's working. So I presume that the copper attacks do happen. I've, in fact, heard of that happening, particularly in rural developing areas of the world. For the other types of attack, particularly, okay, so for the other types of attacks, more than network-based attacks, are these threats, or what are you seeing these actually occurring, and if so, what are the motivations for them?
I don't know the it's catching the attackers is hard, and generally that involves catching the attackers on attacking, for instance, a power grid involves men with guns, right? As opposed to involving, like as not, most of the people in this room, right? So it's mostly a matter for law enforcement in terms of catching them and then identifying their true motivation.
Are they happening that you know of?
Yes. These are all attacks that we've seen. These are all attacks that are live in the field. We routinely see copper theft. It's a huge problem, and I presume anybody else running wireline stuff sees this especially in any area that is not megalopolis is seeing this. the jamming attacks that you've seen. I mean, there have been cases recently of people jamming GPS and hijacking drones. I mean, it's there's this kind of stuff is absolutely coming, and it's getting more and more and more. The built-in security of things like the LTE and GSM cell encryption is simply not good enough, let alone the stuff that's built into Zigbee or any of the other or WiMAX or any of the other levels. So any kind of sensor technology needs an additional layer if you want to prevent it from being used as an amplifier. And if you want to see a real amplifier, compromise your sensor network and have the 3 million toothbrushes start sending DNS queries to somebody. So as far as they were saying about Paul was saying about the botted fridge, don't worry about fridges, worry about toothbrushes. So, any questions?
Thanks, David. Larry, you want to come up? Anyone want to jump up and introduce themselves? I'll pick on somebody. Charlie, come on. Get up to the mic.
Charlie Arrington, Team Cumry. I'm in operations with James Shanks as well. If you need anything, shoot us a note.
Anthony Williams, also go by the name of Albie, and I'm with Verizon Security.
Heather Schiller. I used to be Verizon Security with Alvy, but now I'm at Google Fiber.
I would like to know one thing about Heather, that I would trust her to watch Patrick's kid. Who would you trust, Patrick?
Okay, my name is Larry Blank. I'm with Merit Network, and I'm going to talk a little bit about RPKI and IRR integration. I hope most of you are familiar with these two terms here. I'm assuming most of you are familiar with IRRs. They've been around for quite a while, and RPKI is some work going on in the IETF. It's also been going on for quite a while now. So let's just get started. I'm not going to really do a deep dive into RPKI. There's too much to cover, really, but the basic idea is to use public key cryptography with X509 certs, which have extensions to cover IP addresses and AS numbers, both v4, v6 addresses, and so these are specific extensions that have been documented in RFC 3779, I think, or something like that. And then those are in turn used to sign what are called route origin authorizations. This is just one use of the resource certificates that can be used for other things. But right now, a lot of work has been put into these ROAs. So basically, they're signed statements. I guess they're called CMS signed blobs. So you take one of these certificates, and then you have a CMS blob that has origin and IP address range, and you can actually have multiple ranges within one of these ROAs. So you can have multiple V4 blocks or V6 blocks, and there's one AS number, and you can actually have multiple ROAs for a block. So if you want to originate a block from more than one AS, you would actually create multiple ROAs for that prefix. So again, I mentioned this. It also contains an expiration date, and you can also specify a maximum prefix length. So if you have a prefix and you have a /16 and you want to allow anything up to like a /18, you can say a max length of 18, and it's a more compact way of doing that than having a separate row for each prefix. So obviously that would get out of hand quickly. If you have a /16 and you want to allow up to a /24, it's a lot more efficient to do this than to have 256 different rows. So these rows are they're being published in the same repositories as the resource certificates, and so basically rsync is the current mechanism being used to download these as a distribution protocol. So right now there's a number of the RIRs are operating repositories that contain these certificates and these ROAs. And once you download them, you follow the certificate chain to actually validate the ROAs. So when you download them, you have to verify them and do the crypto to make sure that they're actually valid so that you can trust them. As far as integration work with IRRs, there has been some work done in the IETF under the CIDR working group. There's a draft RPSL-SIG, and that's been around for about 4 years, I believe. I think it went to last call back in May, but it didn't actually progress beyond the last call. Is Sandy Murphy in the room? I'm not quite sure if anybody knows what happened. But, so the idea is to add a signature to existing RPSL objects using these resource certificates. And it's actually kind of generalized, so you can use it with several different object types: Route 6 OTNUM, AS block, INET num, and INET 6 num objects. So here's an example of this signature attribute, and you can see it contains a number of fields here. The first field is a version number, version equals 1. The C is the certificate URL reference. So we don't have the full URL listed here, but so it's an rsync URL, as I mentioned. M is the signature algorithm. T is a Unix timestamp. A specifies which fields in the object are being signed, so you actually have to specify which fields the signature is covering. And then B is the actual signature itself, encoded in base 64. So this has some issues. If you want to use the signature with existing IR tools, you have to do all the signature validation, and that can be time-consuming to have to update your tools to do that. It's not real trivial work to do that. It also creates additional work for users if they're already doing ROAs. If they want to maintain both ROAs and these signatures, there's 2 separate steps involved, so you have to remember to do both of them. And so it's just, users don't like to have to do things twice, I don't think so. Another issue that has come up recently is many of the IRs are using what are known as a hosted model for their certificate authority. So rather than delegating certificates to users, the IRs are actually hosting certificates for users, and the users don't actually have a certificate they can sign the RPSL objects with. So right now, the IRs are concentrating on the ROAs, and in order to support these RPSL signatures, the IRs will have to support this, because the users don't actually have they don't hold the certificate. It's actually being held by the IRR. So our idea is to look at some more something specific involving the ROAs themselves. The ROAs are very similar to the existing route and Route 6 objects in RPSL. And so the idea is to actually use the ROAs to validate existing route and Route 6 objects. And so instead of using the certificates themselves, we go down a level and use the ROAs instead. And it's not quite as generalized. It's only going to cover the route and Route 6 objects. We're not dealing with the OTNUM and the other types of objects. So right now there's an individual draft on this ROA status attribute is what we're calling it right now. So there's a concept of generated attributes in RPSL, where instead of a user supplying the attribute, the server actually generates an attribute and returns it with the object. So ROAs can have one of 3 possible states when you're doing validation. So it can either return a valid response, invalid, If the ROA if there's a covering ROA, but the origin AS does not match what's in the route object, that would be an invalid route object. And then finally, unknown if there's no covering ROAs for an object. So in addition to the status, we include a timestamp to indicate the last time the object was checked against the RPKI, so it's kind of a freshness indicator. And then a URI link to the rsync URI link to the ROA itself if it's a valid or invalid status. And then finally the max length from the ROA. I mentioned that you can have a max length field, and that actually provides some additional value add to RPSL, and I'll show you an example here. So in this case, they have the ROA status, and like the signature attribute, there's value pairs, so there's a version field. So S is the status field, which I mentioned can be valid, invalid, or unknown. And so in this case, there's a valid covering ROA for this route object for 198.108.00/14. The M field is the max length field. So in this case, the ROA actually has the max length specified of 16. So it means that you can announce anything under this /14 up to a /16 would be considered valid. And we get a lot of questions from people who want to actually specify a max length in the route object. And RPSL, when it was specified, didn't provide any mechanism for actually doing that. So by adding this extra attribute where you can, by using the ROA, you can actually add a max length to your existing route object. Right now we see people often will just register every possible more specific route object for every, so you get a lot of these pollution in the IRRs from people registering all these more specifics, because while they may not be announcing them all, they might want to announce them for traffic engineering or to respond to a prefix hijack or something like that. So they just register every possible more specific. And then finally, since this is valid, the U field specifies the URI for the rsync for the ROA. So if you actually want to do the validation, you can fetch the ROA itself and perform the validation. As you can see, they're kind of lengthy. So in the internet draft, they made that kind of an optional field. So our idea is you could maybe have a flag you specify in a whois query if you actually want that field. Since it's so long, you may want to just, you're probably only interested in the status field, whether it's valid or invalid, so you may not really care about the URI if you're not going to actually do the validation yourself. There's no real point in looking at that. So there are some issues with this attribute. You have to trust the IRRs that since it's doing the validation for you, you're not doing the validation yourself. So if somebody hacks into the IRR server and messes with the objects, there can be an issue there. So if you're concerned about that, you can do your own validation on ROA. There's another issue with the AARON repository. They actually have a license agreement in order to get their trust anchor to do validation. You have to sign this relying party agreement, which says that you won't redistribute validated ROA information. And I've spoken to AARON about this, and they have indicated that this would likely violate that agreement. So their concern is liability. Since we're publishing this status information publicly, they're concerned that somebody, again, may hack into the server and do something bad or corrupt the data. So that's an issue we're talking with AARON about right now. So right now we're looking at modifying some of the existing IRR tools, such as IRR tool sets, to use this information. So another alternative which would not violate the AARON agreement would be to modify the tools to actually look at a local ROA cache. So in that case, you would have to actually create your own validated local ROA cache and you would be signing an agreement with Aaron directly to get their trust anchor and do your own validation. That's it. Any feedback?
I'll start off, Larry, since I'm so close. So two comments or questions. First, and it won't be specific, maybe to perhaps the IRR piece, which is maybe your focus. The work itself, I wonder if you see similarities, or are you encouraged by the DNSSEC deployment with the work that is going on in the CIDR group and the BGP-SEC stuff in general? Or will it take someone like Dan Kaminsky to get people to deploy this sort of thing? The second thing is, once this starts getting deployed, what does it do to the flexibility to perhaps do things like route poisoning or other things? Will we lose something that we may wish not to lose because of it?
I think there's been quite a few concerns expressed on the mailing list, specifically about the ability to respond to attacks quickly and do traffic engineering. And since there are propagation delays with these ROAs, and you typically only refresh them like once a day or something. So if you want to do something quickly, I've heard feedback on that issue. There is work actually with using DNSSEC to do something similar to the ROA with using the ARPA and IP6.ARPA to create these objects in the DNS that are similar to ROAs, but using the reverse tree instead. And the idea is it's somewhat simpler, and the DNSSEC stuff is pretty widely deployed at this point. So some people feel that that's a better approach, simpler approach than the ROAs, RPKI.
I'll do an intro and ask my question at the same time. My name is Brian. I was actually a contractor at ARIN. I'm a software developer, so I've worked on RPKI and their IRR and the reverse DNS. So one of the problems or challenges with RPKI and BGP-SEC is that you need to have the entire set of ROAs right in order to determine this. And it's actually, in most RIRs, every 8 hours, not every 24 hours. So this needs to be churning constantly. You need to return you need to pull, right, via rsync, the entire repository all the time, and to continuously be doing this. And while that helps for generating your filters, if you have a process in place that's generating your BGP filters from an IRR today, if you're not doing that, at some point I think that this becomes more work and less secure than just using RPKI and in future BGP-SEC. And with regards to Rover, the BGP information reverse DNS, it solves the problem, right? You can get just the ROAs that you care about, not all of the ROAs. But the challenge there is that while it works for origin validation, there's some issues, I think, with path validation and other things that need to be done to secure BGP fully. Origin validation, right, presents misconfigurations and hijacking, but not leaks. So, and if anyone wants to come talk to me, I'm total geek for this stuff, so
I think,
find me later.
I mean, I see this sort of maybe as a transition mechanism, since there are people who are using tools right now, IRR tools right now, and it's going to take a while for them to deploy new router code to support the ROAs and the router, the protocol to download the ROAs into the.
Yeah, I agree. And I actually think it's a great idea. I think that to ease transition, right? It's easy for anyone to go sign their get the resource cert and sign their ROAs today. You can do that right now, just fill out a web form, no big deal. But to actually start using the data once it's published, it becomes a lot more complicated. So anything that eases that, I think, is a good idea.
Warren Kamari, Google. So with regards to the CIDR RPKI, CIDR RPSL SIG draft, I think there were only 2 sets of comments submitted during the working group last call, when they had a bunch of useful stuff in them, and the working group asked the authors to incorporate the comments, but they, I guess, got sidetracked. Or
Thanks.
Thanks, Larry. If anyone wants the last opportunity to come up and just introduce themselves real quick, now's your chance. Or if you just want to come up and talk about any other security issue. We have about 15 minutes. Otherwise, we can all rush to beer and gear. If for some reason you want to meet some people in the community, you can always come up to me, and I'll either introduce you to other people I see or know, or help kind of get you introduced to the community as well.
Hi, good evening. My name is Yuzaimi Yusuf. I'm from Telekom Malaysia. Telekom Malaysia is an incumbent player in Malaysia for telco data and voice services. We have 8 POP in the US, so I'm basically managing those POP right here in the US. Yeah. Thank you.
Jake Meckler, Director of Operations at Dyn. So you're probably familiar with Dyn from 2 different products, but we have security-team at dyn.com, dyn.com, and that is for anything you want to talk about, whether it's any attack, or we also have, obviously, our free product, which a lot of the botnets use. So we are definitely interested. If you see activity, please let us know. We may not be able to shut it down right away because we don't want them to let us know that we're onto them, but we do want to know the information. Thank you.
Did you see my bit when I did the any stuff? Did you have?
Yes.
Okay. If maybe you can't say it at the mic, but if you have any additional information that I don't have, please don't.
Yeah, I mean, we talked about it at the last NANOG, and a lot of those slides I totally agree with. I will say that we did try blocking any for a while, and we had negative repercussions that for some reason, there were certain there were certain companies that were calling us and saying, hey, because of something that we do with any, we're now not trusting you, and so we had to re-enable it. And so what we ended up doing is we put a filter in place that just watches it, because as far as we're concerned, any shouldn't be happening very much or at all. So we just basically did an RRL equivalent with our own scripting and just shut it off after a couple of tries. So
hopefully, Ed, you were paying attention there.
But yeah, no, we're definitely keeping an eye on it. I mean, I wish I had a better answer, but I also agree with the sentiment that if we block it, they're just going to move on to the next thing. So, you know, things like BCP 38 is very, very, very important.
There's actually an update to that. Everyone keeps saying BCP 38. There's actually a newer draft.
So, well, whatever that draft is, we need to make sure everybody knows about it because it's very important. Thank you.
Hi, everyone. James Ashton from Wide Open West. Just wanted to say hi. If we have a couple million homes, et cetera, and you know, if anybody has any problems with anything in our network, feel free to say hi. I'm always around and listening.
At least one more.
I'm Joe Perez with Wide Open West Data Center. I actually run security there at the data center, and I was hoping you could put your email address up again.
I'll give you a business card if you'd like.
Yeah, that'd be great.
All right, thanks, ladies and gentlemen. Hopefully I'll talk to some of you who I haven't met yet. Maybe at the Beer and Gear. If you come at me with a couple beers in your hand, that helps.